There's also a way to calculate torque using components. So if you're not given magnitudes and relative angles, then instead you can use the component method for finding torque. And this one I'm not going to go into too much detail. Those that have had vector calculus would have already have seen it, and those that haven't, you will not have been introduced to it yet. You just have to know that this method exists and that we don't make you memorize it. In fact, we do put it on the equation sheet. And so this A cross B, if you're given AX, BX, AY, BY, and AZ, BZ, then you can calculate A cross B by looking at how those different components line up. And again, it's a matter of taking your perpendicular components. So if we're going to look at the X component, then it's actually going to be the Y component of A times the Z component of B minus the Z component of A times the Y component of B. So you can make some sense of it in that it uses the perpendicular components in order to get your X, your I hat direction for that vector. Plus, and then we're going to have our Y direction vector, which is just AZ BX minus AX BZ, and that's J hat. So you might have seen it with a minus here, although these terms would be switched. So this is equivalent to anything you might have seen before. And again, if you've seen this before, you can do whatever you're comfortable with. This is just the equation that we do put on the equation sheet that allows you to calculate torque using the component method. So again, note that your order matters. And specifically, torque is going to be equal to R cross F. It's not equal to F cross R. All right, so that concludes our video on Newton's second law with rotation, and more specifically, understanding and finding torque.